Good morning, ladies and gentlemen. John Belkowitz, David W. Harris from Intelligent Concrete, where we specialize in making concrete do the impossible. We've got a fun coffee talk prepared for y'all. It's going to be a quick 5-minute talk, our analysis of a photo that you should be looking at in front of you. And I guess it's more like our reaction to and what we think happened. So what is this? It's a job site in lower New York City, lower Manhattan. We don't know where the job site is, who the engineers are, or even the contractors. But we had somebody send in this picture, and it really is a great photo. It's very artistic.
It's an interesting photo.
Interesting. So to describe the photo, it looks like a concrete parking structure. We've got some concrete square columns. What do they look? 18 inch by 18 inch, 25 feet tall, attaching some concrete beams that are applying a flexural resistance to some T-beams that make up either, I guess it would be a two-way slab.
Probably.
And then those all connect to a slab, and I think that's what we wanted to talk about. And if you're looking at this photo, we were wondering, first of all, the photo looks like it's a day before or maybe 2 days before they're about to put a concrete slab on top of a concrete slab.
Sure looks that way. Looks like they've already enlarged the interior columns.
Oh, I didn't even see that. Oh my gosh. Did they cut them?
It looks like the other way. It looks like they cast some additional concrete around the column.
Dude, that is so awesome. So it looks like somebody came over to an inspector, an engineer came over to the job site, or either looked at the plans and said, "Uh-oh, boys, we've got a bit of a problem here," because the slab looks like they're increasing it by at least 10 inches.
It's hard to tell. I think they're going to increase it to maybe 10 inches. I think that's the top of the new pour that we're looking at.
Holy shit. Wow. Yeah, so they've got some dowels that you would use for a transfer load from the column to the slab, or, it really should be to the foundation. That's where your triaxial state, your triaxial state is going to occur.
Right.
So, does that really work? Is that going to be a true load transfer from the column to the foundation?
Unfortunately, I'd have to think about that a little bit. It's not clear to me that it's going to work that way.
Right, no. Hey, for my kids at Stevens Institute of Technology who are doing that CE 484 class, this is a bonus question for you. If you can figure out if this is going to work, assuming that those J-hooks that were drilled and epoxied into that base or that slab, if that's going to work or not, give me a good explanation. I'll give you a bonus point on your final exam. But I'm going to throw this out there. I don't think that's going to work. Unless it looks like they saw cut into that slab so that it would float onto the foundation.
I don't know. It's a mystery. It looks like they're using these bent rebars to try to transfer the load into the new top of the slab.
There's a whole section on that in 318 on dowels for shear capacity.
Right.
Because that's where your punching shear happens.
Right.
And that's what we talked about with Moore's Circle. And yes, folks, there is a real use for Moore's Circle. It's not the most annoying, useless thing in the world, like your appendix. It actually has a use to it, and we covered it last week. And what we found is, in that area, you have not only your uniaxial compression from your loads coming down into the column to the foundation, but you have to imagine a column footing, an isolated footing, as like a reverse one-weight slab with a cantilevered column. So you also have that bending stress, which means you're going to have some shear and you're going to have some tension load in there too. So you just got a whole bunch of shit going on, which we have a greater capacity for stresses, but there's more induced at that localized area where the column meets the foundation. That's why ACI, I don't know what is it, chapter 7 or chapter 10, has a whole section on those dowels And for those of you in that class at Stevens on reinforced concrete, we just went over that during your spring break. What class was that, Whitney? That was after spring break while we were at ACI. Yeah. So that was in our when I was at ACI and they did that pre-recorded session. We talked about this in here, and shoot, this is it's right here. It's chapter 8. That it goes into columns and distributions of loads and shear reinforcement. Yeah, whoever designed this, I kind of feel bad for them.
Well, I'd have to put it on paper myself to be sure, but I'm also a little concerned about embedment length on those bars.
Oh, totally.
I mean, they look kind of short for embedment.
Well, that looks too short for splicing.
Oh, it could be splicing. I hadn't thought of that.
No, but there's embedment length too. There's that development length for pullout.
Right.
And I think it's like ln over 18 or ln over 24. But that would be for a span. But you still have some type of, like between those column supports. But you still have some type of span that you have to take into account for your embedment length.
For the splice. Yeah. Anyway, it's an interesting picture for sure.
I just seriously, it's hitting me again that they made the columns. What is that? 2 inches thicker on each side?
Yeah, it makes you wonder if they had enough bearing area in the first column.
It could be. Let's take it from a different stance. Let's take it from more like the opportunistic, putting positivity out to the world. It could be that somebody went and bought an old structure. Because one of the things that Whitney and I learned, when we worked in Manhattan and Hoboken, is that anytime there was construction, it was like a matter of national security. Like an entire street and the neighboring streets got shut down for a week, and that just killed the entire town. So if they bought an already in-place structure that, for all intents and purposes, were great, they just had to beef it up for either computer manufacturing to reduce vibrations, or they're going to start putting heavier equipment in there. I mean, it could be that they're just beefing up the building.
That seems pretty likely. I bet that's exactly what's going on. And maybe they have higher traffic loads on that parking slab than they originally anticipated. Maybe they're bringing in trucks now instead of just cars, something like that.
One of the things we saw in Manhattan years ago was these elevators for parking structures. Mm-hmm. So you would drive your car into this elevator and it would bring it up. And what we found is they were trying to reduce the column size and trying to bring more and more and more, or not reducing the column size, reducing the amount of columns, and maybe making some other columns either thicker or making them with a different material, so that they can start putting more materials in there.
Yeah, this seems pretty likely like it's a rehab improvement. I mean, look at that fire protection. It looks brand new. Look at that HVAC.
Oh, totally.
It looks brand new.
That being said, though, why wouldn't they go all the way up? I feel like you're causing a stress gradient in that column now.
Yeah.
It's going to be more rigid down here at the bottom, and wouldn't your stress gradient increase where the rigidity increases?
It would seem like it. Yeah, it seems like you'd go all the way up to that T with the increase in size.
And maybe they're going to come back and do that.
Could be. Looks like that maybe more than one pour as it is. Looks like there's a lift line about 2/3 the way in height there.
Oh yeah, and it's at the same spot too.
At the same spot. So it seems likely they're going to continue on with that pour.
That all being said, I'm going to go back to what we said before about the bottom of that column. That just doesn't jive with me. I mean, totally. Let's put it on paper. Maybe we can write an article about it. And remember, for my CE 484 kids, let's make it to the end of the semester. If anybody sees this and they can give me a good explanation, I'll give you an extra credit point on your final exam, and talk about whether or not that change in the foundation, I mean, that's what it's doing. They're trying to do that load transfer.
Right. And connect into the new pour.
You can even see where they drilled and doweled it into, or epoxied it.
Yeah, it's more than we can solve in 5 minutes.
Well, it's been 10 minutes, so we should have solved it. That's double the time.
Yeah.
All right,
Okay.
listen.
World peace in 15 minutes. Okay.
Done.
You know.
So thank you very much for your time. If you have any questions, don't forget to send us a direct message. Oh, David, sorry I covered up your face there.
Good move on your part.
Let us know what questions you have, especially about this photo. We're going to try to do this at least once, if not twice a week. It's fun for us. Go concrete, beat asphalt.